In this video, we will be looking at methods for balancing chemical reactions. Reactions involve chemical changes in matter resulting in new substances. These reactions involve rearrangement and exchange of the atoms to produce new molecules. We start out with what we will call reactants, sometimes called reagents, and end with what we will be calling products. So in a chemical reaction, the starting material are called reactants. The ending material is going to be called products. A chemical reaction is essentially a written statement. It states the quantities, the chemical identities of the substances in the reaction, and their physical states. For example, if we were to look at the combustion of methane as a gas, we have our reactants, which would be methane, CH4. This parenthesis and parenthesis G in the middle tells us that what comes before it is a gas. So we have methane in the form of a gas plus twice as many oxygen molecules also as a gas. These two reactants combine together to give our products. Here we have carbon dioxide also as a gas plus water as a liquid. The water ends up being produced twice as much as the carbon dioxide. So the numbers or coefficients that are in front of each one of our chemical formulas indicates how many of those particular molecules or atoms are being involved in the chemical reaction. A balanced chemical equation can tell us a lot about a particular process. It provides information about the reaction, whether we're looking at molecular or ionic formulas of the reactants and products. It tells us the states of the reactants and products, whether they be as a gas, which will be represented with a G inside a set of parentheses, a liquid, which will be represented by an L inside a set of parentheses, a solid, which will be represented by a lowercase s inside a set of parentheses, or as an aqueous solution, meaning that it is dissolved in water, which will be represented with an AQ set inside a set of parentheses. Each one of these immediately follow the molecule that they are referring to. A balanced chemical equation also tells us the relative numbers of reactants and product molecules that are required or are formed as the reaction takes place. We can use a balanced chemical equation to determine the weights of the reactants used and the amounts of products that can be made. While there are many different methods for balancing a chemical equation, we will use the following step-by-step method. We will start by looking for the compound that has the most different elements. We will put a 1 in front of it unless you see a good reason to put a different number. Then we will focus on one element at a time, balancing those molecules that contain that element. We will leave molecules that contain only one element, such as ions or elements, until the very end for our balancing. We will multiply once we have numbers in front of everything to get rid of fractions. And when we are all done, we will need to check to make sure that everything is balanced, including the charges. Let's now apply that method to balance 4 different chemical equations. The first thing in our method is to find the molecules with the most different components in a unbalanced chemical equation. So our first equation that we're going to be looking at is SO2, sulfur dioxide, reacting with O2, oxygen, to produce SO3, sulfur trioxide. In looking for the molecule that has the most different types of elements, we find that we have a choice of either SO2 or SO3. Realistically, it does not matter which one you select to use. However, I will be using the SO3 because it has a larger number on the subscript of the oxygen, but it really does not actually matter. Here I'm going to put a 1 in front of the SO3. Now, in order to balance this, on the other side, I look and I see that I have a sulfur first, and so I look to see on the other side if there are any other locations with sulfur. We find that the first molecule has sulfur in it, and so if I have a 1 on the right-hand side in front of the SO3, then I need to have a 1 on the left-hand side in front of the SO2 in order to have the same number of sulfur atoms on both sides. If I have a 1 in front of the SO2 on the left-hand side, then I have 2 oxygen atoms on the left, but I have 3 oxygen atoms on the right. So to balance this out, I would need 1/2 of an O2 molecule, because the oxygen, O2, comes in pairs, and I only need 1 oxygen atom. A way of thinking about this, more mathematically, is I have 1 times 2, 2 oxygens coming from the SO2, plus some number times the 2 that come from the subscript on the oxygen is equal to 1 times 3, this 3 being the subscript on the oxygen on the right-hand side. Solving for n, you'll find that n is equal to 1/2. So erasing what we have, now everything has a number in front of it. What we want to do is get rid of fractions. So if I take the entire balanced chemical equation and multiply it by 2, that would get rid of my 1/2 fraction for my O2. This gives me 2 SO2 plus 1 O2 goes to give 2 SO3. Often in a balanced chemical equation, if there is a 1, we leave it out. We don't put the number in front of a molecule if there would normally be a 1 there. The next thing we need to do is check to make sure that this chemical equation is balanced. So we will make a chart of our reactants and our products and make sure that each element is the same on both sides. The first thing we would want to do is figure out which types of elements we need to balance. So I have a sulfur and I have an oxygen. On the left-hand side, I have 2 sulfurs, so I'll put 2 there. On the right-hand side, I also have 2 sulfurs. On the left-hand side, I have 2 times 2 plus an additional 2. That gives me 6 oxygen on the left-hand side. On the right-hand side, I have 2 times 3, giving me 6 oxygen on the right, which means that this equation here is balanced. Moving to the next one, first thing I need to do is figure out which molecule has the most different number of atoms in it. My first atom in the balanced chemical equation, or first molecule, only has 1 type of element. The next one has 3 different types of elements. I have a hydrogen, sulfur, and oxygen. Then the next one I have aluminum, sulfur, and oxygen. And then the last one I just have hydrogen. So when deciding which one of these to use, I have a choice of either the second one or the third one. Both of these have 3 different numbers. Both of these have 3 different types of elements. Looking at it, I would select the one on the right-hand side because it has more SO4s on it, and this will help prevent having to work with fractions. So I'm going to put a 1 in front of my aluminum sulfate, putting a 1 here. To get this to balance out, if I have a 1 in front of my Al2 SO4 taken 3 times, to balance out my aluminum, I have a lone aluminum on the left-hand side. But I'm going to save this more towards the end because we will be balancing things that are all by themselves later. So I'm going to now look at my SO4. We can take these, the sulfate ions, and treat them as a group. On the right-hand side, I have 3 sets of sulfates because I have 1 of the aluminum sulfate molecules, and that has a subscript of 3 here that tells me I have 3 sulfates. So to balance this out, I need 3 sets of H2SO4. Now, I've used up my SO4s. Looking on the left-hand side, I can balance my hydrogens that I just introduced by putting a number in front of H2SO4. And I can realize that I have 3 times 2, giving me 6 hydrogen atoms on the left-hand side. The only other location where hydrogen is as a product over here. So to balance that out, I will need 3 sets of H2. The last thing that still needs a number is this aluminum here. So if I have a 1 in front of my Al2SO4 taken 3 times, to balance out my aluminum, I will need to put a 2 in front of my aluminum on the left-hand side. I don't have any fractions, and so I can now proceed to making a table to make sure that the number of atoms on my reactant side is the same as my product. So I'll do reactants and products. I have aluminum, I have hydrogen, I have sulfur and oxygen on both sides. On the left-hand side, I have 2 aluminum. I have 3 times 2, so that gives me 6 hydrogen. I have, again, 3 times 1 sulfur, so that is 3 sulfur. And then I have 3 times 4 oxygen, so I have 12 oxygen atoms on the left-hand side. On the right-hand side, if I have a 1 in front of my aluminum sulfate, I have 2 aluminum, I have 1 sulfur times 3, so that is 3 sulfur. I have, in terms of oxygen, I have 4 oxygen in my sulfates times the 3 here, because there are 3 sulfates, so that is 12 oxygen. And then last, I have 3 times 2 sets of hydrogen for 6. The numbers agree, so this is a balanced chemical equation. Let's do the next one. The first thing I'm going to do is look for the molecule that has the most different types of elements. My first molecule is AgNO3, so there are 3 different types of elements there. The chlorine only has 1, AgCl only has 2, and N2O5 only has 2, and then the oxygen at the end only has 1 type of element. So the one that has the most variety is the first molecule, and so I will put a 1 in front of here because I don't immediately see a good reason to do another. Although one could argue that the 2 here on this N2O5 would tell me that I need to put a 2 in front of the silver nitrate to make sure that the nitrogen balance out. But this will work even if I didn't notice that. So let's keep it as is. 1 AgNO3. So if I have a 1 in front of my silver nitrate, my AgNO3, that means that I would have a 1 in front of my silver chloride. The next thing that I can balance is my nitrogen. The only other location of nitrogen is over here for my N2O5. So if I have 1 in front of my AgNO3, then in front of my N2O5, I would only need 1/2 of these to get the nitrogens to balance out. Because each one of these molecules has 2 nitrogens, I will need 1/2 of that number. 1/2 times 2 is 1, and so that will balance out my nitrogen. The next one is my oxygen. If I have a 1 in front of my AgNO3, then I have 3 oxygen on the left-hand side. Now, because there's multiple different locations, I'm going to write out a mathematical expression to try to figure out what number goes in front of this oxygen. So on the left-hand side, I have 3 oxygen. 3 times 1 is 3. That is equal to 1/2 times the 5 oxygen on the N2O5, 1/2 times 5, plus my number in front of this oxygen, that N times 2. So 3 is equal to 1/2 times 5, which is 2.5. So this is equal to 2.5 plus 2N. In order for this to work out, this quantity, my 2N here, has to be equal to 0.5. right? In order to make the two sides equal, I need to add 0.5 onto the 2.5. So the n value, 2 times the n value, has to equal 0.5. And so n would be equal to 1/4, which is 0.25. So the number that will go in front of my oxygen here would be 1/4. Cleaning this up to give myself some room. I still have, in front of the chlorine, Cl2 here, I still need to balance this. The only other location where chlorine exists is in my silver chloride here. And so if I have a 1 in front of my silver chloride, then I would need 1/2 in front of my chlorine molecule. So now each one of my molecules has a number in front of it. So now what I'm concerned with is getting rid of fractions. If I look through each one of these, if I multiply the entire chemical equation by 4, then I can get rid of my fractions. Multiplying it by 4 gives me 4 AgNO3 plus 2 Cl2 goes to give 4 AgCl plus 2 N2O5 plus 4 times 1/4 is 1, so that would be just O2. Now I got to figure out if this is balanced, so I'm going to look at my reactants and my products, making my table. So I have silver, I have nitrogen, oxygen, and chlorine that I need to make sure balances out. On the left-hand side, I have 4 silver, I have 4 times 1 nitrogen, so I have 4 nitrogen. I have 4 times 3 oxygen, so that gives me 12 oxygen. And I have 2 times 2 chlorine, so that means I have 4 chlorine atoms on my left-hand side. Now I got to make sure that my right-hand side balances out. In terms of silver, I have 4 silver. I also have 4 chlorine. So I have 4 silver, 4 chlorine. For my nitrogen, I have 2 times 2, so that is 4 nitrogen. For the oxygen, I have 2 times 5 gives me 10, plus an additional 2 gives me 12. The numbers are all the same, so this is a valid balanced chemical equation. Now, looking at the last equation, first thing I do is look to see which one has the most different types of elements. So I have MgAs, I have HCl, AsH3, and MgCl2. Each one of these has 2 different elements in it. So what I'm going to do is I'm going to use the one with the largest subscripts. This will reduce the likelihood of me having to resort to working with fractions. So the one that I will use will be the Mg3As2. So I'm going to put a 1 in front of here unless I see a good reason to do otherwise, which I don't. So if I have a 1 in front of that molecule, then I have 3 magnesiums. The only other location where magnesium is over here. And so I will put a 3 in front of my MgCl2. Next, if there is a 1 here, then I have 2 As. The only other location for that is over here. So if I have a 1 on the left-hand side, to balance out the As, I will need 2 of them. Now I only have one molecule that doesn't have a number in front of it, my HCl. I can balance this with either the hydrogens from my AsH3 or the chlorines from my MgCl2. We will result in the exact same number. I'm going to use the MgCl2. So 3 times 2 is 6, To balance out the chlorines, I would need a 6 here. If we were to use the ASH3, it would be 2 times 3 is 6, and we would get the exact same number. So everything now has a number in front of it, and I have no fractions. So what I'm going to do is write out my table and make sure that everything ended up being balanced. So I'm going to write out reactants, products. I have Mg, As, H, and Cl that I need to make sure are balanced. On the left-hand side, I have 3 magnesium. I have 1 times 2 As. This is an S, not a G. I have 6 times 1 hydrogen, so 6 hydrogens, and I also have 6 chlorine. On the right-hand side, I have 3 sets of magnesium. I have 2 As. I have 2 times 3 is 6 hydrogens, and I have 3 times 2 is 6 chlorines. So because all the numbers are the same, this is also a valid balanced chemical equation. The key part here is just start and methodically go through it. It generally doesn't matter which one you start with, as long as you start. The other thing to keep in mind is that it's very important that you check to make sure that all the atoms are the same on both sides. As you're going through and balancing chemical equations, it's fairly easy to make a mistake. So it's always a good idea to double check your work via making these tables that we were making.